For section 3, we're going to look at trig functions of general angles. So we're going to find trig functions for those general angles, and then we'll look at finding trig functions for reference angles, which is where your special right triangles are really going to come into play. So first thing, we're just going to look at finding trig functions for general angle measures. So I'm going to skip all the way down to the bottom problem here, where it says the terminal side of angle theta in standard position contains the point at -6, 2. Find the exact values, so no decimals, of the 6 trig functions for theta. Well, we're going to plot the point -6, 2 on the coordinate plane. If I do that, I'm going to be in the second quadrant, going over -6 and up 2. Okay, so I'm going to be somewhere up there. I don't need to have the exact location, but I do need to know that I am at -6, 2 up here. And then we're going to make a right triangle off of this. Since our trig functions we know deal with right triangles, we're going to make our right triangle with the x-axis in here. Now, since I contain the point -6, 2, I know that I'm going over -6, I'm going up 2, and I should be able to find this other side c by using the Pythagorean theorem. The negatives don't matter whenever you do this, but I need to do 6 squared plus 2 squared equals c squared. I have 36 plus 4 is 40 equals c squared, and c is going to equal the square root of 40. I want to reduce the square root of 40, so we can look, square root of 40 is the same thing as 4 times 10, just taking out my perfect square numbers. The square root of 4 is 2. Can't take the square root of 10, so I'm going to leave it. So we know that the hypotenuse up here is going to be 2 square root of 10. And now that I know my side lengths, I should be able to find my angle measures. Theta is always going to be at the center, where my reference, we'll talk about reference angle later, but it's always going to be at the right, or right at the origin. So now we can find sine of theta, cosine of theta, and tangent of theta. I'm going to start with those three. Remember, sine is opposite over hypotenuse. So we have 2 over 2 square root of 10. We can do some simplifying. 2 over 2 is 1 over square root of 10. But I don't want the square root in the denominator, so multiply top and bottom by square root of 10 over the square root of 10, which gets us square root of 10 over 10 for sine. For cosine, we're going to have adjacent over hypotenuse, so we're going to have -6 over 2 square root of 10, which simplifies to -6 over 2 is -3 over square root of 10. Multiply top and bottom by square root of 10 over 10 again. Gets us -3 square root of 10 over 10. Next is tangent. Tangent is opposite over adjacent. So 2 over -6 reduces to -1/3. Okay, then we can do our other 3 trig functions. We can do cosecant of theta, secant of theta, and cotangent of theta. Remember, cosecant comes from sine. It's just the reciprocal of sine. So we can use any one of these 3 in here. We can use this first one, 2 over 2 square root of 10. We could use 1 over square root of 10, or we could go all the way over here to what we finished with. I would argue that the middle one is the best. It's kind of simplified. And when I flip it, that's all we do. We go hypotenuse over opposite now. When I flip square root of 10 over 1, it just becomes the square root of 10. Secant comes from cosine. And I'm going to use the middle one again. I'm just going to flip that. So I'm now going to get the square root of 10 over -3. And then for cotangent, I'm going to flip the last one, -1 over 3. Now it becomes -3 over 1 or -3. And there's your 6 trig functions given a general angle.